Hello, welcome back to my YouTube channel. So in today's video, we'll be prepping for the paper 3 practical exam. Now, I'm going to focus mainly on the chemistry paper. However, this advice works for any other subject with a practical exam. I'm going to break down this video into 3 main parts. The first part will involve building up your confidence in your abilities to do well in this exam, because obviously the more confident you feel in yourself, the better you'll end up doing in the paper, right? Now, the second part will involve breaking down the paper itself. So I'm going to be breaking down the chemistry paper. And the third part will involve actually going through a paper together. All right, so without further ado, let's get on with the video. So part 1, I'm going to give you guys all the facts. And these facts I actually ended up getting from the syllabus. And honestly, they calmed me down a lot when I was going into the exam. Because the thing is, I understand how you feel because I've been there, right? I've done the HCC and it's like, you know, it was just theory. But then to actually come in now do the practical exam where you're actually, you know, doing the experiments yourself, it can be a little, you know, overwhelming. But these tips did calm me down a lot, and I hope they help you guys out a lot as well. Okay, so here are the facts. I'm gonna just leave them here for you guys, and I'll be right back. Come back now? You're done? Okay, good. Awesome. So for the second part of this video, we'll be breaking down the paper. So if you notice, most of the papers have 3 questions, 2 of which involve quantitative analysis and 1 that involves qualitative analysis. Now, for the quantitative analysis, the first 2 questions, it will usually be a titration, calorimetry, so enthalpy of change experiment, or you can have rates of reaction, and something that involves measuring a volume, for example. I would suggest to use this information to your advantage. So solve 1 paper of each type of experiment. That way, when you actually go into the exam, you won't be caught by surprise. And the thing is, they're not going to test you in anything that you're not prepared for. Okay, so all the theory is stuff that you've taken before in class and is not going to be outside the syllabus. You might get an experiment that you're not very familiar with, but it shouldn't really matter because at the end of the day, the instructions are given to you, and it'll be something that you've at least seen before. So I definitely suggest watching YouTube videos where people perform the experiments, especially because of Corona, and you know, if you know you're not really allowed to go to school and you're not really given the opportunity to practice performing these experiments on your own. Now, so that's it for the quantitative analysis. For the qualitative analysis, you are, like we said earlier, given the tests and observations. All you actually have to do is practice, like I said before, but even if you don't get the practice, that's totally fine. At least view the sheet, you know, once a day, once a week at least, before your exam shows up. I know your exams are coming up pretty soon, so I definitely try to go over it once or twice a day, or at least visualize. So visualizing is really important. So that's an extra tip I'm going to give you guys. Visualize yourself actually performing the experiments. Even if you don't have the opportunity, open a paper, open a previous exam paper, and follow the instructions and kind of think of it in your mind. Think of yourself performing this experiment. And if you can't think about it, draw it out. Draw yourself performing. Now, you don't have to draw a person, obviously, but you can draw the pipette, you can draw the burette, the flask, any of that kind of stuff, and then just break it down, you know? Break it down, and because you are given 2 hours, you do have enough time, so don't you worry about that. But definitely you don't want to waste time, so that's why going over it, just visualizing it, will help speed up the process. Now, that is all basically for the second part of this video. And now we're actually going to go through a paper together. I'm going to show you guys how I would solve the paper, and hopefully you guys can pick up a thing or 2 from there, or something new that you weren't aware of, and that I didn't just, you know, waste your time on this video. Anyways, I'll see you guys later. Peace out. Okay, so on to part 3 of this video. So we're going to be solving the May-June 2020 paper.
So of course, after placing, my name, center number, and candidate number, first thing I'm going to be doing is going through the questions and taking note of anything that's important. So for example, question 1, as soon as you see record, highlight that. So record the mass, or calculate and record. Then you'll notice that those are the things that they're actually, asking you to do. So you can actually create a little table like I have right there, and once you actually go through the experiment, you can fill it out. Okay. Make sure to remember, so this is something that's really important. Let me grab a different highlighter color. Make sure to always place the units, because that on its own is like a whole mark, and that way you don't have to write it again when you're filling out the paper. Not the paper, but the table, sorry. So yeah, let's move on. We go on to question 2, and we do the same thing. So record the mass, here, record again, calculate and record. Here, measure and record the temperature, then the maximum this one right here. Record the maximum temperature and record the temperature rise, or calculate and record it. So these are all things that you need to note, and so creating a table again with everything that was highlighted, and again with the units. So that would be degrees Celsius, right? And you can just fill it out again when you do the experiment. Let's move on. So here we're asked for the titration. What you need to do is repeat this 2 or more times. I usually go with 3 because 3 is just a nice number. And when you're doing this, you're going to need the initial burette reading, the final, the titer, which is the final minus the initial reading. And then you're going to take the average titration. You're going to add up to 3 and divide up. So you're going to add up the different titers, divide by 3, and that would be your average titer, and that would also be your answer for part B. Alright? Now this is something you guys need to be aware of. To get the full 8 marks, you need consistent results, right? So make sure the difference between each titer is no more than 0.10 centimeters cubed, right? And when it comes to taking the average, for average, make sure to use the values that are no more than 0.20 or 0.20 centimeter cubed apart. Now the reason why we're taking it to 2 decimal places is something you guys also need to be aware of, and it's because the burette itself has these, okay, look, so it starts at 0.0, usually ends at 50.0, and it goes up by 0.1, right? So this would be like 49.9 and so on, right? But the thing is, there is space between each division, and you can assume that it's a 0.05. So say that the liquid ends here, so between 50 and 49.9, so you're allowed to do 49.95. The reason that's possible, or why we can do that, is because when you have this division, so 0.1, you can multiply it by half, and that's 0.05, and that gives you your error, basically. And that's actually one of the questions, I think that is in question 2, where they ask us to find the error of the thermometer. Alright, so let's move on. Now another thing you guys need to keep note of is the units. So moles per decimeter cubed and decimeter cubed. So when we're getting the number of moles, you're going to use this triangle, which I'm sure you're aware of from, IGCSE times. And the concentration is the number of moles over volume. And we're asking for the number of moles, so that's concentration times volume. We got the concentration, which was given to us up here, right? And the volume is the titer that we got. So yeah, where are we? Yeah, so the titer that we got, but it's in centimeters cubed. So we divide by 1,000 to get decimeter cubed. And of course that cancels out. Moles per decimeter cubed times decimeter cubed over 1, basically. These two cancel out. They cancel out because you know how anything divided by itself is just 1. So 2 divided by 2 is 1. Decimeter cubed divided by decimeter cubed is 1. So yeah, it cancels out and you're only left with mole. And that would give you your answer. Now, they told us that 1 mole of potassium manganate reacts with 5 moles of the hydrated salt. So you're going to divide whatever your number of moles were by 5, and you're going to divide by the volume, which was 25, because now the reason why your volume is 25, because if you go back up here, here it says pipette 25 centimeters cubed of the Fa4 into a conical flask. So you use 25 centimeter cubed, and you again divide by 1,000 to get the decimeter cubed, and that will give you your answer. Now for part triple I or part 3, you have you're trying to find the molecular mass. So again, use this triangle, which is mass over number of moles. Now the good thing is we have the concentration, right? And concentration also has number of moles. So mass divided by N is the same as mass divided by the concentration times volume. The volume is 250 because we're asking for the total mass, which was right here. We used a 250 centimeter cubed volumetric flask and we filled it all up to the 250 centimeter cubed mark, right? You guys can definitely pause this video and actually read this paper and then come back if you'd like, or we can just continue from here, alright? So 250 divided by 1,000 is 1 over 4, so you get m divided by c over 4, which is the same as multiplying it by its reciprocal, so it becomes 4m divided by c. Right, so you have the mass, which we found, or which we weighed, and you just divide by the concentration, multiply by 4, and there you go. So now for question 2. So for question 2, when you're getting the temperature, you're going to record to 0.2, 0.0, or 0.5 degrees Celsius, right? And if you want the full the third mark and the fourth mark, you need to make sure your temperature rise is no more than 1 degrees Celsius. Like there's no difference. Well, you know how I told you that your supervisor or your teacher would be performing the experiment before you, and if their temperature rise is no more than 1 degree Celsius different than yours, then you'll be getting the third and fourth mark. So 1 mark for the first experiment and another for the fourth. The reason why it's 0.0 or 0.5, so it's not to 2 decimal places, because we look at the divisions in a thermometer. The difference is 1, so you can have like 50, 51 for example. So again, the division is by 1, you multiply by half, so that's 0.5. So it's plus minus 0.5 basically. And then here to calculate the energy, you know that it's mc delta T. You use the mass of water because 1 centimeter cubed of water is approximately 1 gram. And be careful of the unit here, it's in joules, so we're going to use that. So we're going to stick with grams. So 30 grams times 4.2 times your temperature rise for experiment 1. Alright, so we want to calculate the number of moles. That's easy, so that's just the mass over the molecular mass, and the 106 we got from the periodic table, which is all the way at the bottom. So you have 2 sodiums, 1 carbon, and 3 oxygens. You add up their atomic mass and it'll give you 106. Now use your answer to BI and BII to calculate the enthalpy change. Now you don't really need to memorize any formula, but you know it's kilojoules per mole. So first of all, this is divided by moles, so per mole is just a division, right? So you're going to have energy divided by moles. Your energy we found was in joules. To get to kilojoules, we have to divide by 1,000, and then divide by moles. So the moles you found right here, and that will get you your enthalpy change. The reason it's negative is because there is a rise in temperature, so you know that the experiment was exothermic. If there was a drop in temperature, then it would have been endothermic, and then it would have been positive. But for now, the sign is negative. And you should save it to 2 to 4 significant figures. So your golden number of significant figures is around 3, and the only time you'd use a different amount is when, for example, you're recording measurements. So like the temperature, so that would be to 1 decimal place, and then the burette reading to 2 decimal places. But generally speaking, try to save things to 3 significant figures. You can improve the measurement of the temperature rise by plotting a cooling curve or a graph to obtain better estimates of the temperature rise. So you can, for example, you have your time here, you have your temperature. So until like 5 is a lot. So for 3 minutes, this was the consistent temperature, and once you added the other reactant, it shot up, and then at like 4 minutes, temperature was here, and then at 5 it was here, and so on. So what you can do is extrapolate this line and this line, and then here would be the max temperature. So when it comes to thermometers and burettes, just anything that involves reading a liquid, you definitely want to make sure that you avoid parallax error. Make sure your eyes are parallel to the liquid. So, well, that is a huge thermometer compared to your eye, but yeah, make sure it's at 90-degree angle to get the most accurate value. Okay, so here it says to get the error, which I've shown you how to do that. The division is by 1. The difference between each division is 1 multiplied by half, so that's 0.5. To get the percentage error, we read the thermometer twice, hence y is 2 times 0.5. You divide by the temperature rise, multiply by 100, and that would give you your percentage error. So then on to the qualitative analysis. So just for you to know, I've created these tables, so anything in blue is written by me. So you had this empty space here, and yeah, so definitely before going through this experiment, you'd create the tests, you'd create these tables. Now, it's up to you whether or not you want to create all the tables for all 3 questions and then doing the experiment, or do it for the first 2 questions, do the experiment, and then come back and create the tables for the 3rd one. However, I'd go with the first and just creating the tables for everything, and then going through the experiments and then not answering the questions, right? Until once you're done all the experiments. That's what I would prefer to do, because at least then you'd get the most marks out of it, because most of the marks are given to you by performing and recording your answers. So actually going through the experiment is what's most important, even if you're not the strongest when it comes to these calculations. But if you're just placing down your observations, that on its own right now, it's 5 marks, right? So definitely do that first. So Fa6 contains 2 cations, 1 anion. You know the test for cations involves sodium hydroxide and ammonia, well, the aqueous form of both. So for the example, this reaction, you get a green precipitate and it turns brown in contact with air, insoluble in excess. That is actually a unique answer, so you don't even need to do this, right? That saves you time. So if you go to the qualitative analysis sheet, right here, green precipitate turns brown. Like, for example, the white precipitate, right? So you might not know for sure, but the iron, it's pretty clear, the iron too, so you use that. Now, we can test it by heating the ammonia. So with the sodium hydroxide in the test tube, you can heat it up, and you're going to notice that ammonia is produced on heating. So if you grab your litmus paper, it will turn the damp red litmus paper blue. So that's how you know for sure that there's ammonia gas, right? Now when you're using any sort of heating, definitely use a boiling tube. You don't want to end up getting hurt, so use a boiling tube for sure. So to get the full marks, you need to mention that there's some bubbling and that the damp red litmus paper turns blue, right? So these are your two cations, ammonia and iron. And then to get the anion, they told us either sulfite, sulfate, or halide. You can be lucky and the first test that you do gives you the answer and that saves you time. So for this question, we're going to use barium nitrate and you end up getting white precipitate. And then you need to use a dilute strong acid, so I chose hydrochloric acid, and it was insoluble in that acid, so that tells us that it's a sulfate. So if you go back to your qualitative analysis sheet, you'll find that sulfate would be the answer. Then of course, give the ionic equation, so you can do any one of them. So you can do the iron with the sodium hydroxide. You know for sure if it's a precipitate, then it's just solid right away. The reaction with ammonia would give you gas because that's the fizzling / bubbling. And then here as well the white precipitate, so that's solid. So any one of them would do. And then here we need to find number of moles of water. So you know for sure that's said because they told us the anion, so that's SO4, which is the sulfate. We know that iron, it's iron 2 plus, right? So it's going to be Fe NH4 2, and here it's a 1, but we don't write the 1. The reason it's like that is because of this. You have your oxidation stage, you're going to place them in the opposite place. So the 2 comes down here and the 1 goes there, and then SO4 2 dot W H2O. So they gave us the relative formula mass of the compound, right? That's the full mass of the compound. We're going to subtract the mass of everything else except the water because we don't know how many moles of water there are. There's 2 of this, 2 of that, and 1 of this. That gives you 284. So you subtract it from the total, that gives you the mass of the water. Divide by number of moles, divide by the molar mass, will give you the number of moles, and that would be 18. So there's 2 hydrogens in H2O, so that's 2. There's 1 oxygen, 1 times 2. So it's 1 times 2, and then this is 16. You add them all up, gives you 18. So if you solve for it, W should be 6. And yeah, let's move on. Okay, so here's FA7, FA8. They gave us the test, now we're just going to place our observations. These are the observations that were given in the marking scheme. So going through these tests, make sure, like I said, make sure to place all your observations, whether it's sound, what you see, what you smell. In this case, there is nothing that you're smelling, but yeah, so look at this for example. You notice that there's bubbling or effervescence. So you're going to go back to your gas tests. And for example, you can grab a glowing splint and you notice that it relights it. If it makes a pop sound, then you know it's hydrogen. And yeah, so let's go back up. So you can try any of these tests to see what you get. Okay, so let's move on to actually answering the question. So look at this, the total is 18, but here, just placing your observation, that's 5 marks. Placing your observation here, 2 marks, another 5, so that's 12 out of the 18. So you can get 12 marks out of the 18 without actually solving any of the calculation questions or the theory questions, right? So make sure you pay attention. What are you seeing? And yeah, it's possible, and don't get scared if you don't see any change, because it is possible that no change does occur. You just have to mention that there is no change. But if there's no change for everything, then you know that there's probably something wrong that you need to double check. Now, so From our observation, suggest one possible identity for this compound. Fa is an organic compound. So if you go here in test 3, it's the triiodomethane test, and it tests for methyl ketones. So if you notice here, you got a pale yellow precipitate. That's how you know that there's a methyl ketone present. So you can put any one of them. So you can say ethanol, propane 2-ol, butane 2-ol, or ethanol. And just mentioning all that gives you 1 mark. To get the second mark, you also have to say that there's a redox reaction occurring with the potassium manganate, proving that it must have been an alcohol that got oxidized, right? So if you go back here, the potassium manganate goes from purple to colorless, after heating or placing it in the water bath. So yeah, a redox reaction did occur. So state the type of reagent. Fa7 acts as in its reaction with aqueous potassium iodide. It acts as an oxidizing agent because iodine is formed. If you go up here we have potassium iodide, and we're adding starch. So starch, the starch test from bio class, it tests for the presence of iodine, and you can do the opposite. Iodine can test for the presence of starch as well, right? If either one is present in the same tube, you'll end up getting a blue-black or a dark blue color. So had we go from potassium iodide to iodine, this equation is definitely not balanced, but I'm just trying to explain to you guys. That would definitely be because of the Fa7, hence why it's an oxidizing agent. Because we went from here, halogens have a -1 oxidation state, and potassium is in group 1, so it has a +1. And then iodine, I2, is neutral, so it's a 0. So it went from -1 to 0, so definitely it got oxidized, it lost an electron, because oxidation is loss of electron, right? And reduction is gain of an electron. So yeah, that's how you know that Fa7 acts as an oxidizing agent. It made something else get oxidized, so it itself got reduced, if that makes sense, right? So that's it for the paper. I definitely suggest practicing more and more and getting yourself familiar with it. Look at the mark schemes, look at what kind of observations they're placing down. So when you're doing these experiments, go through it and be like, okay, I should mention this, I should mention that. What do I see? What do I smell? What do I hear? If I see some sort of fizzing or bubbling, some sort of effervescence, then test for a gas, because there most likely will be a gas, right? Okay, so yeah, that is it for this paper.
Alright, so that brings it to the end of this video. I hope you guys enjoyed, and you came out of this feeling at least a little bit more confident in yourself and in your ability to perform well in this paper. I know you can do really well, and honestly, if you have any questions or any other concerns, I'm more than happy to talk to you in the comment section below. And if you guys are interested in a Q&A, let me know in the comment section below, and I'll see you guys next time. Bye bye.